Okay, so today let's take a look at how we can use tree diagrams to determine probabilities of outcomes. Here you have a simple path. I believe they describe this as a corn maze, and if you end up in the right ending, you either gain pumpkins, you get a pumpkin, or you don't get a pumpkin. So what we want to do is, I guess, ask a question. What's the probability of getting a pumpkin? Or what's the probability of not getting a pumpkin? In order to do that, we need the probabilities, and we like to map them out on a tree. So if you take a look at the first option, once you enter the maze, you've got 1, 2, 3 different options. And they're all equally likely of which one to choose, so it's 1/3, 1/3, and 1/3 probability of choosing the first path. Now, as you come down the first path, the top path, you have 2 more choices. So that's 1 out of 2 choices for each path here. Same with the second path. You have 1 out of 2 choices. But the third path, there is no choice. There is only 1 choice for that. So when you end up at the first one is pumpkins, and you would calculate, let's just say for pumpkins, you would calculate its path probability by multiplying the 2 probabilities. This one has to happen, and this one has to happen. So whenever they both have to happen, you multiply it, so it would be 1/2 times 1/3, which would equal 1/6. So that probability is 1/6 chance, 1 out of 6 chances of getting pumpkins, getting it that way. Now, the second one, going this way, is also, this is a no pumpkin, by the way. This is NP, for no pumpkin. So you would still do 1/3 times 1/2. The 2 have to happen in that succession in order. So you have a 1/6 chance of not getting a pumpkin going that route. Also, coming here, you would do, remember that this one's a no pumpkin as well. And so, if you were to take this route, you would do 1/3 times 1/2, which would equal 1/6. And that's this path right here, is 1/6. So, right now, the probability of not getting a pumpkin is either this one or this one. And when OR comes into play, you add the 2. So 1/6 and 1/6, or so it's 2/6 chance total of not getting a pumpkin, or 1/3. 1/3 chance of not getting a pumpkin. And now we can work out these 2 paths as well. So this path coming down is this path right here, if you want to follow it. So that's a 1/3, and that is a pumpkin to get here. So that's a pumpkin. And you have a 1/3 times a 1/2 given 1/6. So to get another pumpkin is a 1/6. And this last one is 1/3 times 1, and it's also a pumpkin. So it's 1/3 times 1, which is just 1/3. So this is basically 2 6s. All I'm doing is just making a common denominator there. So it ends up being 3 6s when we add them, or 1/2. So this whole one is 1/2. And this one here is 1/6. Again, to add those, because either one of those could be a probability of getting a pumpkin. So 1/6 plus 1/2. Of course, we want to get a common denominator there. Multiply top and bottom by 3, right? So it's 3 sixths, which is equal to 4 sixths, or 2/3. Of course, you would want to use calculators for this if you're not good at fractions. So to get a pumpkin, you have 2/3 chance. And no pumpkin is a 1/3 chance. And those are all the outcomes of the corn maze. And so it should add up to 1. All the total outcomes should add up to 1. So 2/3 and 1/3 runs up to 1, or 100% of the outcomes. Either you're going to get a pumpkin or you're not going to get a pumpkin. So there you go. I know it's a little complicated. I know it's could be considered to be a little bit sloppy there, but if you just follow the concepts of listing out your choices and multiplying your probability as you go, it's with a little practice, it's actually pretty straightforward. So I hope that explains tree diagrams to you, and thanks for watching.